Hello folks, today we're going to be taking a look at an old friend that has finally returned. This big green monolith right here is the Facit ESA-0, a machine that was manufactured by the company Åtvidaberg Facit in 1949 to about 1957, and it was a very early, fully automatic calculator. In fact, the name itself, ESA, is an abbreviation in Swedish. It stands for Elektriska superautomaten, which means the electrical super automatic, which is the name that Facit used to refer to calculators that carried out all of their functions with limited operator input. That is to say that, much like on a traditional calculator, you just type in your number, you'd hit your times key, then type in your other, and then you hit equals, and the machine figured it out for you just like that. This machine had a problem. I got it from a very friendly German couple who were more than willing to help me test it out and run some test calculations over the phone, which incidentally happened while I was in America at the time, which made the call very expensive, but well worth it. Anyway, a month later I return home and I find this machine waiting for me. Now, the thing is that I used it happily for about a week, let's say. And then disaster struck. I was trying to record my video on it, as I do. I think I may have recorded videos on earlier Facit machines. I have a few laying around because as a Swede, Facit is extremely dear to my heart. Of course, they're a prime example of Sweden's influence on the calculating history. Same with the original Odhner and other such devices. But I digress. Disaster struck. I had it plugged in while my mother and my grandmother was visiting, and suddenly there was a loud boom and the fuse break, or no, not the fuse, the breaker tripped. And I thought to myself, well, shoot, it must be one of those studio lights like the one you see over there that tripped the breaker, because they were up and about at the time. But no, I flip the breaker back on and it immediately pops off again. Now, me not being a crazy man, I decide, let's not duct tape the breaker in place and instead see what's going on. And I see this thing. In fact, I see a little cloud of blue smoke billowing out from the, let's see here now, it's a heavy thing, billowing out through the power socket here at the far back. See now then, dear camera, could you please? Thank you kindly. And little blue smoke just billowing out. Smells awful, probably tremendously toxic. And I think, oh, shoot, I have ruined this fanciful machine that was in perfectly pristine mechanical condition. It would do all the calculations that I asked of it flawlessly, which was great, and it was dead. So I was distraught. I thought that it had been a power surge that came through and poof, done. But no, it wasn't that. Instead, it was this Bernays that is the root cause behind it all. You see, these machines, when you have an electric AC motor, they cause radio interference that gets all up in an AM radio's business. Back in the day, there would be some troubles with electrically powered car windows affecting the radio. And So you had to design devices to suppress that. And this thing right here, covered in a syrupy tar. If I can hold it up to the camera a little bit. Will you focus? Maybe not, but I'm not going to go digging around in this plastic bag because it is covered in electrolyte. A syrupy thing, looks a little bit like Marmite, probably doesn't taste like Marmite. I'm not crazy enough to find out. You'll have to find a different YouTube channel for that kind of science. Anyway, my point being, this radio frequency inhibitor exploded. It coated the insides with gunk, and the machine wouldn't run anymore. So I've handed it over to an uncle of mine who is a qualified electrician. Because, say what you will, mains voltage is not the sort of thing I mess around with, being a safety-oriented sort. So it came back quite recently, and he had taken this radio frequency filter away and bypassed it, so that this thing does now generate radio frequency interference, but that's fine, because really, who listens to AM radio anymore? And as an aside, it's working perfectly fine now. And I thought that it is high time to give it the tender loving care it so well deserves. So I have compiled some stuff. I have a little bellows. It's good for blowing out dust. I have compiled screwdrivers and tweezers and a magnetic bowl for holding screws, which is going to be useful later. Oh, dearie me. As you can see, it's quite magnetic. I have a little pitcher of water here, because that's going to be good to wipe down the dust. Beyond all of that, I had a blast reinstalling the motor in this thing, because during the course of the fixing, the power switch, which is really a fancy name for a couple of metal pieces that are pushed together by another metal piece, and thus forming a circuit, they concerned me. So I purchased this thing. This is what you would call a ground fault current interrupter, which basically means that if you somehow become the ground, or if power escapes somewhere, this is going to cut the power, and therefore, hopefully, the device will not kill you. Not killing you is a good feature in any device, I find, so I thought natural purchase, really. And then the power cable for the machine is your standard run-of-the-mill Euro plug with a grounding wire. On that note, the case itself is rather quite dirty. If we take a closer look. So the case itself is rather quite dirty, so I brought the wet sponge, or not the wet sponge, the rag that I was intending to wet. But then I realized that it's probably best to remove the decimal markers prior to getting underway, because there's a lot of gunk gathered up under here. And if I have the chance to clean them, well, so much better. Now, some nice fellow described me as a slightly clumsier AVE, which is, quite frankly, for one, very true. For another, it's quite a compliment, because AVE is completely awesome. A delightful channel, I think. I think that if I was able to make a living as a machinist, posting tech vids all the time, man, I would be a happy camper. Another reason I'm a slightly clumsier AVE is because I am not by any shot good at camera work. I mainly really keep the camera in front of my face and do my best to not get in its way. which is tricky when you have tiny screws. And especially when the tiny screw appears insistent on staying on the machine body that you're trying to sort out. Yes, there's one of the spacers. And third one's the charm. Yes, and there's the other spacer. Quite spaced out indeed. Now let's see here. And here we have the decimal indicator for the top registers with the 5 different decimal indicators, 3 on the accumulator, 2 on the counter. That's good to keep in mind for later. As we can see, there's a lot of gunk here. Fantastic. See, now it's beginning to look like someone who has overplucked their eyebrows. Oof, I certainly wouldn't want to do that to myself. It would not be a charming look on me. And you come off. Yes. Good work, little screw. And finally, the last one. Now, I was quite curious to see how dirty these things get. But equally amazing is actually how clean they get when you spend some time sorting them out. So I will simply move this away, and I will take the rag and just dip it very slightly in water. I would be remiss if I got too much water on it and had to wait to play around with the machine because it was all damp. But that's just kind of how things go. The way I see it is that these machines, they are museum pieces. If you ask why I collect them, indeed, what makes me think that they are so incredibly great, it's the fact that this thing right here, this thing was a tremendously expensive, it was a tremendously fancy device, and it was used in an office. It was the trusty workhorse of that office. It was used to crunch numbers, to make invoices, to provide people with salaries. These ones were the driving force behind, well, frankly, a large part of the economy. And then they became rendered obsolete. Just like that. Bada bing, bada boom. Don't pass go. And I find that so sad. It might be a silly thing to say, but imagine that a machine, sometimes I do think that if a machine had feelings, if the machine could consider its predicament, that it was once the top dog of the financial world, of the engineering world, of the science world, and then it's being relegated to some shed somewhere. I wouldn't be surprised if this was stored in a shed or a dubiously climate-controlled antiques shop. I've certainly seen my fair share of those during my days. And it's just sitting there, unloved, unappreciated. And I think to myself, that's unacceptable. These machines were a significant part of our history and a remarkable feat of engineering. So many people worked on these incredible machines that it's just astonishing to think that their hard work, their effort is left around to be forgotten and only cared for by a few people like myself who just want to commemorate their history. I think there's not so much I can do about this particular part. It's just been scuffed too badly. But that's just how things can be sometimes. So let's see here. I do want to take the opportunity to scrub this off too, because these things, the decimal markers, do tend to be a bit of a pain to work on newly acquired machines, because they end up being absolutely completely filthy. And sometimes I just work around it, especially on machines like the Heyman, where the decimal indicators are actually placed on with what appears to be pins, actually. Alright, Bowl, I understand. You have made friends with the metal object, but now is not the time for friendship. Now is the time for work. Anyway, so I thought that I'd take my time, give this machine a bit of a clean, and oops. Well, now something has left the building, and it's not the king. No, indeed, it's a little spring. This little bent piece of metal is a spring that's providing tension against the inside of the rail. But how does that? Oh, it sits at the top. Very curious. Let's see if I can get that to get back in there. So after much ado, I managed to get the spring back on. Let's see if I can get it back onto the sliding rail. Yes. Yes, I could. So, there we have the decimal marker back in place. Now then, I'm going to put them towards the middle, or rather, I'm going to put them towards the end like this. And then I'm going to keep a steady grip on it so that it doesn't try to escape. I will move this to the side, and then I can just take my rag and wipe the rail. One side at a time. It's quite relaxing to clean up an old calculator, because you know, it really does improve a lot of things. Of course, the paint on this one does have some slight, what I believe to be water damage that I'm not sure how to deal with. Again, gorgeous old machines being kept in sheds. It is a disgrace, really. Now then. Yes, there we go. Looking good, quite shiny. And the decimal indicators are decent looking as well. A little bit of tension there perhaps, but that's all well and good. So it's time to reattach the first rail. And I think the best way to do that is to take a screw, thread it through the hole, and then take one of these spacers and also thread it onto the screw, and then carefully and in a controlled fashion, because this looks like a part that is going to be fiendishly likely to try and roll away. Line it up with the screw hole, thread it in just enough to prevent unwanted escapes. Next up, I will do an equipment switch. I will take my needle nose and put it back in, and I will take my focus and I will pick up the default to close tweezer. Now, when I first saw one of these tweezers, I was quite weirded out. I was like, a tweezer that standardizes to open? How can this be? But it could be, and it's useful. So if I take this and pinch it, we'll see that this tweezer will actually hang on to it rather quite readily. Presumably if it slips, it's going to launch a few ways away. Another grabby thing is this bowl. Perhaps it would have been smarter to put it somewhere else, but one cannot be smart all the time. Except for maybe smarter every day, I suppose. You can't really get smarter every day if you don't stay smart, I guess. Who knows, really. And then the final one is just gonna be a simple matter of letting the pressure from the rail itself hold it in place. While I carefully maneuver it with the tweezer, take a screw and insert it into the hole. And there we have it. One cleaned assembly. And then I need the screwdriver, which is conveniently hiding out of my sight. And I can reattach this. Yes, thank you, camera. You are focusing on the truly important things in this movie. And there we go. And the decimal pointers are ready to point once more. Now, so what I'm going to do to mount this in place is that I'm going to be taking my always closed tweezer, put that in front of the hole with a washer in it. I'm going to take the decimal indicator and put it in place. But first of all, I will be threading a screw through it. So screw and washer and hole. and thread it in a little bit by hand, just to make sure it stays where it should. And leave a little bit of play for later. Second try, same as the first. Take the tweezer with the washer. Take a screw, thread it through, washer in place, screw through the washer and into the hole. Season and finish up with screwdriver to taste. And we have 2 cleaned decimal counter rails. Shiny, nice digits. Life is good. We are back in business again with the decimal indicators back in place. Looking good. Sliding quite nicely, of course. And I managed to position the correct amount of indicators in the correct register. So all well and good. Now let's have a look on the inside. Now first things first, if I tilt it up and simply find the wheel, and there we go. Now this thing is wheeled, so turning it around on the table should be a simple matter. So I need to remove this part. This is a counter control lever that inverses the direction of some operations. It's interestingly enough controlled by the mode selector lever. So you see, for division it gets inverted compared to the other modes of operation, such as multiplication, addition, and so on. And interestingly enough, shifting it to division and back resets the setting to normal. But it must come out for the body of the machine to come off. Well, the cover of the machine rather. Then it just needs a bit of screwing to get the entire cover off. And it's a flat head that has been stripped by some fiendish villain. And I think that this is gonna be, yes, that's a good bit for it. And I just install it into the trusty ratchet screwdriver. That's not going to want to come off on its own. I can feel it. Should have used the extension. And again, I hardly do need the ratcheting functionality because it slides out really rather quite easily. Other side, same as the first. This thing is quite heavy to maneuver, which is why it would come with wheels, so that if you're working with a machine like this, you could simply lean it forwards. And I need a better grip. You could theoretically lean it forwards, but not if you're sitting behind a camera and you have a subpar positioning to get leverage on the machine. Anyway, 2 screws come out and the cover slides off. And so, here we have it. The inside of the Facit ESA. Now, what we're looking at here is the basically the main gearbox, I guess, practically even the drivetrain. And I'm not even going to attempt to explain all of the different things going on in this calculator, because frankly, a lot of it I don't quite get. I know that we have the main powertrain coming in here. So here we can see from the motor we have the camshaft made out of some bakelite material, so that in case of a breakage, this thing breaks first. Then up here we have a slipping clutch as well as a fiber gear, so that it's a sacrificial gear, so that in case something goes amiss and there's a blockage and the motor keeps running, this part should break first. That's because this one is designed to be easy to replace, unlike the stuff inside the main gearbox itself. Now let's see if we can have a look at the power equipment, which will show why I was so concerned to mess around with it. Here we have the two power prongs that connect to live and neutral, unpolarized, and we have a grounding attachment that connects to the grounding prong on the outlet. This metal part is attached to the body by a quite long, quite hefty screw, so that it's basically, the ground is connected to the entire metal construction, as well as to the outer casing by a spring to the side. And over here we have the main power switch. These two metal reeds go into the machine, and at the far side in here there is a little leather piece, a hardened leather piece that's designed to insulate it from the remainder. But these parts are indeed live when the machine is running. So that's quite exciting, I think. So here we are looking at an internal photo of the power switch, with the two power cables coming in and out of it, as well as the top half of the reed going in deeper into the machine and connecting up to this brown bit that is the hardened leather that I mentioned. As you can see, this leather is doing a pretty good job of physically insulating the switch from the rest of the machinery, but you are still looking at a piece of metal that's, well, having live current in it, surrounded by other pieces of metal, bridged by an air gap. So we can clearly determine that electrical safety was hardly invented at the time that this machine was built. Now, here's the machine, uncovered in all its glory, and plugged in, ready to go. So let's have a look at just some of the behaviors. I will be posting a more comprehensive video later, but I need a sturdier table, because when we look at the division, we will see that Facit's design is entirely encompassed around this part right here. This is the pinwheel hidden behind this metal plate. Other calculators, like the Monroe, which uses a stepped drum version that has many small drums, about, I would say, this big, around this size, spinning around like this. And that's actually quite a nice, very stable design, because it's not a lot of weight being thrown around. The Cellatron has the proportional lever system, where in an earlier video I show that there are several levers arranged in racks like this, and when you do a calculation they're gonna move a proportional amount. So the bottom bunch with the higher digits are gonna move longer, upper ones move shorter distances. So it doesn't result in much weight being thrown around. See? They'll shift a certain amount. The lower line shifts a lot more than the or the lower row. This one, however, has this massive pinwheel that is quite heavy, a little bit off balance because it's not super evenly weighted, and that results in a lot of force jostling the thing around. So if I press add now, you will notice that the table shook quite a fair bit. You may be recognizing this as me setting up a division for pi. And now watch this. Now this sort of thing has been known to cause tsunamis in smaller countries. So please, if you find and come across a machine like this, use it with care. And don't put your fingers in here for God's sakes, because look at this. And of course we have our pi over there, remainder, and the divisor. And you clear it. Like so. Now, it has a quirk. This is fine. It clears nicely. This, however, results in the clearing mechanism getting stuck on the last digit, so it needs another prod to bring it down to 5. And then it clears. And even so, there's still some sticking there. I suspect that there is something that needs a little bit of lubricant to get the rest of the kick out, because when I was working through this by hand, by fiddling with a gear over on that side, it turned out quite nicely. So let me cut the power, and we're gonna get this part off. And let's have a look at the pinwheel itself. And now the power has been safely cut. Let's see if I can use the same bit I used when taking the cover off. Doubtful. So instead I'm going to use a slightly smaller one. Let's see here. I think I have a good feeling about this one. So yes, that one will do just fine. And I will use the extension. Aye. No injury. The fact that some people say that blood, sweat and tears go into these videos when they do works of art. On occasion they are not wrong. Not so much sweat and tears. Tears maybe when the capacitor exploded, although they were more of the quiet internal kind, like a silent storm. Now, I detected something quite curious, is that from one thing to another as I'm working on this, I've noticed that a lot of my videos keep being appropriated by various channels. And it's not super common, but it's happened. And it's quite interesting that people take the interest in my videos as they do, which is not something I would have expected at first. And now, very recently, I hit 3,000 subscribers, which is approximately 2,099 more subscribers than I would have expected. So that was quite interesting, and I'm glad to see that there is such an interest, even though the interest does not seem to be strictly mechanical calculator related, which admittedly had me confused for a moment initially. Anyway, so we have exposed the pinwheel, and we can see that now if I press on the clearing button, we can see the entire mechanics, which is that a little sled engages and pushes into the pinwheel, and something tries to pull the pinwheel back. The interesting part is that if I put these numbers in, I clear it, it's going to be quite heavy because it has to pull against a really big spring. And as you can see, as the pinwheel is being brought back into alignment, we can see that there is some difficulty there. It seems as though there is some sticking between the pinwheels, which could be explained by the fact that there is a lot of what appears to be dried grease on the side here. Yes, something is indeed behaving quite oddly. Yes, it does indeed have some major problems clearing when the rightmost part of the carriage is misaligned. Now, yes, and that is as far as it will go. And it resets. Very curious. Yes, there is definitely something that is out of alignment. So now the pinwheel is exposed, and I can press and move it to the center one, and I press the add key, or repeat add, which will start making the pinwheel do a revolution. And we can see what we can see. Let's try another one of those. And of course nothing got added, because we still have zeros recorded in the pinwheel. So, but it was still slightly out of the initial alignment, which is curious to me. Let's try. And 2, 3, 4, 5, 6, 7, 8, 9. So 9 digits in total. And I press repeat add. And the pinwheel comes unblocked. And it begins the turn. And we will now see that it engages with the counter, or accumulator. And we can see that the reason is that all of these pins compared to how it was when we had zeros input, is that all of these pins are now extended, including this set here, which get extended when we have a 5 input into the machine. Now, I'm going to take this opportunity to bring out the sewing machine oil and give it a little drop in each of the 5s. We'll see if that does anything for the clearing. Really though, why is it getting misaligned like that? It's strange. There we go, another add. And let's attempt a clear. Still being quite slow and unhappy about the state of things. And another clear. Yes, it's still behaving curiously. If I try to do a subtract, which would make it rotate in the other direction. Yes, there is quite some friction here compared to the other ones. Let's get in there. I would presume that it's actually inertia that's bringing the carriage back up here, because I've never had any issues when running it automatically, so that's quite curious. Now, if I press on add, it's going to do an automatic add operation, and so the pinwheel is engaged, and it should not be having any trouble here. Although it did need some help because I was not really strong enough to do it by hand. But then after the add is completed, it should clear itself. And this one is still posing some resistance. Now, why this one does not clear is a fair bit beyond me at this point. I noticed though that it does behave a lot nicer when inputting numbers. So the lubricant has helped some. So if I just keep working the machinery, perhaps so there's also this one railing here. That needs some attention. And of course the inertia would have thrown it back. Now, subtraction. And a clearing. Interesting. Let's plug it back in again, see how it behaves. Okay, so we do an addition, subtraction. And much like I thought would happen, the inertia is returning the pinwheel to the original position. This would of course not happen when I was doing it by hand. Now if I press on add, we still see that there are some issues. Where it just won't return to 0 as it should. Which seems to have something to do with the force of the carriage moving. Now I actually had a misinput because I pressed on 8. Why is it doing that? Very, very odd indeed. And I would say that that's about the only really computational error I'm seeing on this machine. It is rolling on a linear bearing, so there shouldn't be too much friction going on throughout the side, but perhaps that's just the way the cookie crumbles at times. Now, let's have a look at this division for pi again, but this time with the entire pinwheel exposed, and you will see why it is such a mobile machine. I'm clear to make the distinction between mobile and portable. This is all metal and weighs 12 kilos. My poor table. And the stuff you see rotating around here in the back, that's the carry wheels that are responsible for making sure that all of the counters carry as they should. Now, if I clear that, you probably wonder, how much is 12 kilos in pounds? Well, let me show you. 12 kilos is 12 times 2.2, and that is to say 26.4 pounds. It does have another issue, which is that I need to hold this button or press it really firmly. Oops. Because otherwise, when I press it, the engine starts a cycle, but it doesn't latch the clearing until it reaches the far bottom, so I have to wait for an engine cycle to complete. So that's cool. That being said, I do need to do some reading up before I can get the clearing error fixed. That said, it's such a minor error because everything else in this machine is really, really clever and works quite well. In fact, if you look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, into the multiplier register with you. 9, 8, 7, 6, 5, 4, 3, 2, 1. Now, watch how the counter register behaves now that I run this. And you will see a vast difference between this, the Monromatic, and the Celatron. Let's see if you can see what it is. Interesting. We exceeded the capacity of the machine by multiplying those two massive numbers together. Which makes sense. This can represent 13 digits. This can represent 9. This can also represent 9. Now, with that in mind, 9 digits times 9 digits is way more than this can represent. So we had a computational error. Fortunately, it was quite conspicuous, so it wouldn't sneak its way into some annual report. Let's try this again. 9, 8, 7, 6, 5, 1. Into the multiplier register, and another clear to get rid of the erroneous 5. And then I just write 2 here. The number in the multiplicand doesn't really matter all too much. I mean, except for the fact that it makes the pinwheel look damned cool, but that doesn't really belong here. Now, watch the counter register and see what it does. Did you notice something interesting? You see, it did a shortcut. It figured that going from 0 to 2, to 3, to 4, to 5 is the fastest way. But from 0 to 6 is less fast than going from 0 or from 9 to 6. So it turned the other way. And it did the same there, and there, and there. Let's look at that again. 9, 7, 6, 5, 4, 3, 2, 1. Times 45, let's say. Of course, it gets a little bit confused when it comes to the end because it cannot actually do the shortcut it wants to do. very satisfying. And for the time being, I have one more thing to show you. What makes the engine not overspeed? Overspeeding in a machine like this can be quite troublesome because it depends on precision. If you, for instance, run the clock a little or the motor a bit faster, maybe some springs don't have the time to work. So it can impose timing issues and undue wear on the parts. So let's look at the unsung hero of this machine, the Ozoninator 2000, also known as the motor governor. Now then, let's clear it. And then the power needs to be cut. Big old screen that goes above the counter register to show you which numbers you have input needs to be put back on. And for this, I'm going to get a number so that I can see that it has been correctly aligned. So, first screw. And the second screw. We'll see here that if someone provided us with a machine in this sorry state, we would probably be rather quite cross with them. Now then, let's have a look here. Ratcheting screwdriver, very helpful when inserting screws, provided it is set correctly. There we go. And now if I look at the alignment looks fine. So I can just put this in just the same. And there we go. I will be doing a manual clearing operation, which is basically just me using my finger to mess with the fiber gear, in case you were wondering what I'd been doing previously. Clothink. Good going, good going. Next up, I need to replace the bit I was using with the bit that I will need for the machine cover. Take away the lid. Get the body of the machine and slide it on. Clink. Ouch. My toe informs me that the screwdriver is surprisingly hefty for what it looks like. Such is life. There's one. And there's the other. Sort of. Not quite. I purchased a nicer tripod that has a central column that moves and shifts about to the right, and also a ball head. Initially I was so used to the old-fashioned style of tripod head that I wasn't too much of a fan of the ball head, really. It seemed quite imprecise to me. But then, one day, I took my camera, I set it up so that the ball head would... Well, I basically loosened all of the various screws on the tripod, and I realized I could position my camera however I wanted with one hand and use the other to lock those settings in. And since then I have been sold on the ball head. Finally, we have the inversion screw. Brilliant. So, when we look at our accomplishments today, we can say that we have given the machine some lubrication. We have taken the great liberty of cleaning it up, even though the cleaning hardly helped. Taken some of the screws out, fixed up the decimals. Some screws decided to do battle, and so tweezers were required. And a whole lot of looking around and actually managing to show off the insides of the machine quite nicely, if I do say so myself. Even though it still has some problems with the clearing, which I'm not entirely sure how to solve, but I am a tenacious kind of person, so I will not give up so easily. Beyond that, I hope you enjoyed this video. Please feel free to comment. I'm a big fan of those. Please feel free to subscribe if you like to look at calculators or whatever other random nonsense I might decide to upload. This is a channel of curiosities, and they take many forms. A lot of them are mechanical calculators, but they can be games and other such activities too. Finally, I would like to wish you all a tremendously nice day, and nag you again to leave a comment, because I do like those. Have a delightful day, wherever you may be. Thank you so much for watching.